In this video, we're going to try and understand a bit more about the inverse function. So imagine you've got a function here. Let's just say f of x here equals this. So this is f of x. Well, if this here is f of x, then this here is the inverse function. So the inverse function of this is this here. And I've done several videos on this. So if you start with f of x equals this thing here, and then blah 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 here, um, will blah 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 here, and then that would take you to the inverse function, which is this here, x minus 1 over 2. I've done several videos on this, so if you don't understand it, watch some of the earlier videos. So the inverse, so starting out with this, with our function here, f of x here, then we worked out our inverse function. So going back to here. So let's just say we start out with this function here. This here is our inverse function. Now, when you put 0 into this function here, then you in effect putting the 0 into this x here. So this, when you put 0 into x here, this here will become 0. So that will spit out the number 1. Okay, if you put in the number 1, so this bubble here will be 2 plus 1, that will spit out the number 3. Okay, so if we try and plot this on a graph, hang on. So remember, if you put the number 0 into here, it will spit out the number 1. So let's try and plot that on the graph. So this is our graph here. This is our graph here. If you put in the number 0 here, that will then spit out the number 1. Okay, so it's like that. And by the way, this here is x, and this here is our f of x. Okay, so here, going back to here, if you put the number 1 into this machine, if you like, the machine here, then it will spit out the number 3 here. So if you put in the number 1, it will spit out the number 3. So it will be there. If you look at this, if you put in number 2, it will spit out the number 5. So going down here, if you put in the number 2, it will spit out the number 5. So basically, our function will look something like this. Well, it's really a straight line with an intercept of 1 and a gradient of 2. So it's basically a straight line. Okay. Well, anyway, so this is our f of x here, f of x. Okay. Now looking at this here, if you come to look at the inverse function, now if you put in the number 1 here, so the inverse function is the one that takes you from here back to the original input. So for example, if you put the number 1 into here, okay, so 1 take away 1 is 0. 0 divided by 2 is what? Yeah, 0 divided by 2 is 0. So when you put in the number 1 here, it will spit out the number 0. So when you put number 1 here, put it into the machine, it will spit out the number 0. So going down here, now we are going to plot a graph of our inverse function. Okay, so when you put in the number 1 here, it will spit out the number 0. So that will be right here. Okay, I'm going to use purple for this one. So going back to here, if you put in the number 3 into our inverse function, if you put the number 3 in here, okay, 3 take away 1 here would be 2. 2 divided by 2, it will spit out the number 1, which makes sense because if you put this back into this machine, well, it will spit out the number 1 here. So when you put the number 3 into here, the inverse function would tell you what you originally put in. Okay. Well, when you put 3 in here, it will spit out the number 1. So going back down to here, when you put 3 into the machine, it will spit out the number 1. So it will be here. Okay. If you try and put in the number 5 here, if you try and put in the number 5 into this machine, 5 take away 1 is 4. 4 divided by 2, it will spit out the number 2. Okay, which makes sense here. So if you put in the number 5, it will spit out the number 2. And if you continue, well, if you try and draw a line of well, if you try and draw this function here, it's like you plotting a line of y equals x minus 1 over 2. So that, well, from our section on graphs, you can break it up as this. Hang on, yeah, you can break it up as this, and then you can visualize it as this. It has a gradient of a half and an intercept of minus a half. So if you try and draw this function here, it will look like this. Remember, it has an intercept of a half. It has a gradient of a half. So look at this. It has an intercept of a half here, and a gradient of a half. So if you try and draw that line, it will look something like this. Hang on. It will look something like this. Let me think. Here, and then here, and then here, and then here. So it will look something like this if you try and draw a straight line here. Okay, if you draw this the original function. Hang on, let me think. Here, here, here. So the original function would look like this. You see, this here is our inverse function. This here is our normal function here. And the thing is, when you come to create your inverse function, what's happening is it's really being reflected along this diagonal line here. It's a definite reflection, because if you think about it, when you put 1 into the original function here, it will spit out the 3. So the 3 here, it will spit out the 1. If you put in the 2, and then it will spit out the 5. If you put 5 in here, it will spit out the 2. If you put a I don't know, 4. Yeah, if you put in a 3 here, it will spit out is it 7? Well, it will spit out whatever this is, and then 7. Put it into there, it will spit out the 3. So what's happening is that if you have a function, and then to create your inverse function, it's really a reflection along the y equals x line. So it's along the diagonal line here. Even if you're in the negative realm, it's still a reflection along that line. So an inverse of a function is in a way a reflection along the diagonal line of the original function. Okay.